take this question, WAEC 2001 on galvanometer. A galvanometer with a full-scale deflection of 1.5 times 10 raised to power minus 3 amps has a resistance of 50 ohms. Determine the resistance required to convert it to a voltmeter, reading up to 1.5 volts. So let's quickly do that. Now we have to write out our parameters first. The first parameter here is a full-scale deflection of that amps. That is galvanometer current. That's the current that will make it go full scale deflection. Is what? 1.5 times 10 raised to the power of minus 3 amps galvanometer current. So the next one has a resistance of 50 ohms. That resistance is the galvanometer internal resistance, represented by small letter r, equals to what? 50 ohms. And say determine the resistance required to convert it to a voltmeter, reading up to 1.5 volts. Okay, that's voltmeter reading 1.5 volts. So they say determine the resistance required. That's the external resistor, or you call it the multiplier. What we mean by multiplier is the resistor connected in series with the galvanometer, so that it can extend the range of voltage or can increase the voltage needed to give it a full scale deflection. So we are looking for big R. So if this is your galvanometer at full scale, you have to connect a multiplier, or you say a resistor, in series with it. So this is the resistor they say we should find. Here represent internal resistance of the galvanometer, while here is a I subscript G. So it is R that we're looking for. So recall from the relationship on how to convert a galvanometer to voltmeter. Voltmeter reading equals to what? Galvanometer current into a multiplier plus internal resistance of the galvanometer. Then from here, if we are to make big R, since is the one we are looking for, the subject of the formula, big R will be equals to a voltmeter reading divided by galvanometer current minus the internal resistance. So if we substitute into that, voltmeter reading is 1.5 divided by that, which is another 1.5 times 10 raised to power minus 3, then minus R. R is 50. R is 50. So if we process that, 1.5 will cancel 1.5, and 10 raised to power minus 3. If you take it to the numerator, it becomes 10 raised to power 3. So we have 10 raised to power 3 minus 50. 10 raised to power 3 is 1000. 1000 minus 50. 1000 minus 50 is 950 ohms. So the resistance required to make the galvanometer to read a voltage up to 1.5 volts is 950 ohms resistance. So if you connect a resistor of 950 ohms, you extend the range of the voltage the galvanometer to read. It will be able to read up to 1.5 volts. So that is the answer. Thank you.